to graph and write piecewise functions. But prior to that, we are going to look at inequality symbols. How do you read inequality symbols? And so, like, we're just going to review a little bit. The inequality symbols below are usually with numbers or variables. Just remember, the inequality symbol there, maybe your teachers in the prior grades told you that this was a less than symbol. It is not a less than symbol. All right. It depends on which way you're reading it. So just remember, when you're reading an inequality, this side right here, on this side, this is the small side. You see how it comes to a point? That is the small side. This is the large side. All right. So if you're reading towards this direction and you have x is smaller than 5, x is smaller than 5, x is less than 5. 5 is larger than x, 5 is greater than x. So just look at the inequality symbol. You'll see the small side. When you're reading towards that small side, you say less than. When you're reading towards the larger side, you say greater than. So always read from the variable to the number, and we're going to translate these into words. So we're going to have x is greater than 7. So we're just going to say x is larger, greater than 7. And then numbers that satisfy that inequality, it's just greater than 7, 8, 9, 10, 11. And then we're going to put a dot, dot, dot to just go on forever in that direction. X is less than, you're reading from the variable out to the number. X is less than 10. So, satisfy that inequality, less than 10. And we're just going to put less than 10, 9, 8, 7, 6, 5, and then dot, dot, dot. X is greater than or equal to -5. Greater than, I'm sorry, not greater than or equal to. I thought I saw a line under there. Just greater than -5. So, greater than -5. We are not going to put -5 down. Again, -4 is greater than. -3 is greater than -5. -2 is greater than -5. -1, and then dot, dot, dot. So this one right here is the one I was looking at. X is greater than or equal to 0. The or equal to is that line. It's basically half of an equal sign. So it's greater than or equal to 0. And the numbers that satisfy that inequality is 0 because that's the equal to part. 1, 2, 3. All numbers that are greater than or equal to 0. And then we're going to put that dot, dot, dot. And that's basically the review. In compound inequalities, what a compound inequality is, it's basically two inequalities smashed into one. All right, you always put the variable directly in the middle, and you read from the variable out to the left side and the variable out to the right side. So the open unshaded circle is just less than or greater than. The closed circle is the less than or equal to or greater than or equal to. So if you're looking at a graph right here, this is basically how I like to annotate on top. The x is all the numbers in between the -4 and the 3. So then I put -4 here because that's circled, and 3 because that's circled. And again, x is all of these numbers are greater than or equal to, because it's a closed circle, x is greater than or equal to -4, and all of these numbers here are less than or equal to 3. So the inequality, we put the x in the middle, the greater than or equal to -4, x is greater than or equal to 3. The interval notation, and again, you just put the two numbers down, -4, 3. And since they are both closed circles, we have a bracket on each side showing that each number, 3 and -4, are included in the inequality and satisfy that inequality. Again, with two closed circles, so I'm just going to put x in the middle, and I am going to put a -1 here and a 6 here. Just annotate right on top. So all of these numbers here, 0, 1, 2, 3, 4, are greater than or equal to -1. And all of these numbers here, 5, 4, 3, 2, 1, are less than or equal to 6. So when we put that inequality down, that is x is greater than or equal to -1 and less than or equal to 6. And again, with the brackets, because both of these have closed circles, which means that both numbers are included in the inequality. So going to the adding target, remember the prior knowledge was the prior knowledge that we just basically did and reviewed. So the do now says give the domain in the range of the function represented by this graph. This graph is known as a line graph, a line segment, a graph of a line segment. So it only starts here and ends here. Notice there are no arrows, so this is not a line, this is a line segment. So the domain, let's talk about the domain. Remember, that is a list of all x's that satisfy this inequality, this graph. And then the range is the set of all y's. So let's talk about the domain first. Since it ends here, we're just going to go ahead and take a look at what the domain means. So the domain, basically, we're going to start right there. So it's right here, and then right up there is the x-axis. So -3 would satisfy this line graph. So this line segment graph. And then this right here, this closed circle, is -4. So you could, this +4. So we're just going to go ahead and put those numbers in. And those are the numbers for the domain. So my domain, we're taking a look at the domain, is a x right directly in the middle, the -3 on the left-hand side, and the 4 on the right-hand side. So all the numbers here are greater than or equal to -3. And then all of the numbers this way are less than or equal to 4. So we are looking at either A, the domain of -5, that's out, -4, 5, that's out, and there's -3, 6, that is out. So answer without even doing the range, but let's go ahead and do that range. Since the range is basically the y values that the graph is kind of like exists in this graph, the y values stay the same. Notice that this graph goes along this line. So that line right here, what we're talking about, and I'll do that in red so you can see it, this is -5. All along that line, and it doesn't go anywhere else for the y. It is -5. So when we're talking about the range, we're talking about the y values. And notice that the y values or just y, is equal to -5. And that's the actual line, right? This line is y is equal to -5. And that's why it's this right here that you could see that the domain exists between -3 and 4 and includes -3 and 4 because these are closed circles. And then the range is just the y is equal to -5 along that horizontal line, has a 0 slope, y is equal to -5. We're going to spiral back for a second because we have to know how to graph a line, right? We have to remember that we could use our calculator, or we could do this by hand. So first off, you can't even use your calculator or do anything by hand yet because we have to solve for y. So let's go ahead and solve for y by dividing by 4 on both sides, right? We have to get this into y equals mx plus b format. So the 4's cancel out and y comes down equals, and then we have this, see this positive 2 over 4x. That is 1/2 x. And then we are going to divide -4 divided by +4. -4 divided by +4 is a -1. So by hand, we have a slope of 1/2 and a y-intercept of -1. And we would put the arrows next to it, a rise of 1 and a run of 2. But let's go ahead and put this directly into the calculator first because I want to make sure that you could use that calculator. It's going to help you. Remember, it's 1/2 x minus 1. So we're going to put 1/2, this is alpha x, which is 1/2 x minus 1. Then we could press graph and we could see what the line is going to be. You see how it crosses -1 on that coordinate grid, and it also has a gradual increase because remember, when a slope is close to 0, it is kind of like not as steep. The further away from 0, the steeper the line. So this line makes sense. It's a positive slope. It goes up 1, runs 2, crosses at -1. But let's say you didn't want to do this by hand. You press second function table and graph. And then we go to the table of values. Since we have the table of values, and I'm going to just say, we're going to go to -10 first because this is where we could fit on this 10 by 10 graph. So it's -10, -6. So we're going to go -10, which is right to the left, and -6 is 1, 2, 3, 4, 5, 6. And we're going to put a point there. -10, -6. You see -9, -11 over 2? I am going to skip that. Anytime I have a fraction or decimal that I don't want to graph, and the next one is a whole number, I'm just going to skip it. -8, -5. I'm going to go -8 and then -5, 1, 2, 3, 4, 5. And put the point there. Then I'm going to skip this one and then go to -6, -4. -6, 1, 2, 3, 4, 5, 6. And -4 is 1, 2, 3, 4 down. Now, you know from slope that you have a rise of 1. You see the rise of 1 and a run of 2. Rise of 1, run of 2. I'm just going to keep on going that way. And notice that I'm not going to look at my calculator until I get to this -1. And I know that this -1 it is 0. It should be 0, -1. That is my y-intercept. And you see it there on the bottom. And I am just checking to see that I'm actually graphing this correct. Then I continue with that pattern because this is a linear function. Remember, linear functions remain straight and they have a constant slope. So that's my line. This is a line, so I am going to put arrows on both ends. And then I am just going to go ahead and put y equals 1/2 x minus 1 on the line. Again, you could do this by hand, but I would rather you use the calculator because you have to get used to using that calculator. Okay, so now here's our first piecewise function. All right, and a piecewise function is a function made up of two or more equations. And you can see this right here is y equals x minus 2 if x is less than or equal to 0. I'll talk about that. And the second line is y equals 2x plus 1 if x is greater than 0. So each piece applies to a different part of the domain. Okay, so here we go. Let's do the first one. Just do one at a time. We're just going to go ahead and take y equals x minus 2. You could see this, y equals x minus 2, and I broke it apart for you. So we're going to graph it on the calculator. So we're going to put y equals, clear the last one out, and then we're going to put x minus 2. So this is the graph of x minus 2. Makes sense. Has a slope of 1. It goes up. As in a constant rate. It crosses at -2. It rises 1, runs 1. So taking a look at this, I'm going to go to second function table. And I'm going to look at the table. Now, remember, you're not just graphing this line. You're graphing a piece of the line. And the piece of the line that you're graphing is x is less than or equal to 0. So we're going to go back to the table, and it has to be less than or equal to 0. So I'm going to go down to 0 on the table. 0, -2 is the first point that I am going to graph. So 0, -2. And I'm going to put a closed circle because it is x is less than or equal to 0. Less than. So we're going to graph part of the x minus 2 line that has an x that is less than or equal to 0. Anything greater than 0, it is not going to be graphed. All right, so let's go back to the calculator, and the next one that is less than 0 is -1. So -1, -3. Put a nice big point there. And then we're going to go -2, -4. -2, -4. Now you notice this line. -3 should be down here, -5. -4 should be down here, -6, and so on and so forth. The calculator, -3, -5, -4, -6, -5, -7, and you go until you can't go anymore, that you run out of graph space. So you're using the slope right here. Pick these points, and I'm just going to check. This is -8, -10. -8, -10. I'm good. All right. So I am going to start here and connect the points and go further down, further past that last point, and put an arrow. Because remember, you're graphing x minus 2 from x is less than or equal to 0. All right. So that's in this direction. Anything past this, like this is where the line would be. Like if you think, okay, what the x minus 2 line, this would be the rest of it, right? But you don't need that part. You only need the part that says x is less than or equal to 0. So we're going to get rid of that line. All right. So that right there, and we graphed that section. Let me just put a check mark next to it because it makes me feel better. Okay, there we go. Now we're going to switch to this. y equals 2x plus 1 if x is greater than 0. So now we're going to go to 2x. 2x plus 1. I said 2x minus 1. That's not true. So we're going to have 2x plus 1, and we're going to graph it. See, the calculator is going to show you the entire line. And yes, it's a steep line. It has a slope of 2. It has a y-intercept of 1. But remember, the part of the line that you're graphing is x is greater than 1. So I'm going to go to 1. X is greater than 1. I'm sorry, x is greater than 0. So I'm going to go to 0, and that's going to be my first point. And since it's just a greater than symbol, it is going to be an open circle. So I'm going to change my actual color of my pen and graph 0, 1. So 0, 1 is right here, and I'm going to put a nice big open circle. Right? Open circle because it's just greater than and not greater than or equal to. Now I'm going to continue to graph greater than. So I'm going to go down to 1, 3. So 1, 3 is right up here. Then I'm going to go to 2, 5. So this is 2, 5 is right up here. Notice that the slope is 2. If it's a rise of 2, a run of 1, you just continue going like this, and you can't go any further. So I'm going to connect the open circle to this direction, and since it's just greater than, I am going to leave it in open circle and put an arrow on this side. So I am going to, I can't forget to put labels on. So this is y equals x minus 2, and I'm going to put a semicolon, x is less than or equal to 0. This one is y equals 2x plus 1, and I'm going to put a semicolon, and x is greater than 0. And that is a piecewise function. These are pieces of each function. All right, and that is it. All right, so let's go on and go to the next page. So you know that you have piecewise function. Each piece applies to a different part of the domain, and now there's 3. And you could see now it gets a little bit more difficult. But just remember, you're doing one at a time. So we're going to clear this out, and we are going to graph y equals -3 first. And that's the horizontal line of -3. So we're just going to go y equals -3, or f of x. I should put f of x because they're not going to put y. The first graph is f of x equals -3 at x is less than -2. So notice that that's the horizontal line there. We're going to press second function graph, and it is less than -3. So I'm going to just go all the way up, and then I'll go down to -3. -3, -3. So, I'm sorry, less than -2. Yikes. So, -2, -3. So, -2, and it's a less than. So, -2, -3 is down here, nice big open circle. I got to make my open circles a little bit better. So, -2, -3, open circle. And then anything below that, -3, -3, -4, -3, -5, -3, it just keeps on going like this. -8, -3, -9, -3, and -10, and -3. So this piece is pretty easy. The horizontal line just continues on like that. And since it's just less than -2, we're going to put an arrow here. That's the open circle. And then we're just going to go ahead and label it f of x equals -3, semicolon, x is less than -2. And that's it. So now we have f equals 0. In between, x is greater than or equal to -2, and x is less than or equal to 1. So these are the only x's that they want you to graph of y is equal to 0. So let's just go ahead and clear out the 3 and then just put y is equal to 0. That's a very nice horizontal easy line. So if we press second function table and we have to go and graph between -2 and 1, I am going to go down to -2, and there it is, -2, 0, -1, 0, 0, 0, and 1, 0. That's it. So from -2, let's see, to f of x equals 0, and it's only in between -2, less than or equal to x, and then greater than or equal to -2, and less than or equal to 1. So that's pretty easy. We're just going to go to -2 first and keep it on 0, -1, 0, 0, 0, and then 1, 0. And everything is a solid line. Closed circle. So we're going to connect those points. And we're going to try to, it gets a little bit tricky to write small, f of x equals 0, and it is x is greater than or equal to -2 and less than or equal to 1. Then we're going to have another horizontal line because f of x, we're going to press y equals, and we're going to clear that out. And just so we know, it is 3. We're graphing and graph. And there's another horizontal line. Again, slope of 0. So we have to graph this one. Let me just put this in a different color. F of x equals 3, and x is to be greater than 1. Okay, so greater than 1. So I'm going to go all the way down to 1, and actually I'm going to go past it a little bit because I want to see exactly what's after 1, and then I'll go back up. Well, there's 1, 3, 2, 3, 3, 3, 4, 3. So I'm going to go to 1, and then 1, 2, 3. And this is an open circle, so I'm going to put a nice open circle. And then 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3, 9, 3, 10, 3. And since it's just greater than, that's the open circle. And then also we have a straight line connecting all those points and an arrow on the end. So this one is f of x equals 3. X is greater than 1. And that right there is a piecewise function with 3 pieces. And I just put a little bit of just notes here, because I just wanted to make sure that you knew that why we're doing the open circles, why we have an open circle versus a closed circle, and that's about it. All right, piecewise functions, here we go, 3 more. And again, I'm going to start with x plus 2. And really, that is not good. All right, so I'm just going to put f of x equals x plus 2 first. And we're graphing x is less than or equal to -1. So x plus 2, that's what you're graphing in your calculator. You pick up your calculator, you have x plus 2. And we graph it. You see exactly what x plus 2 is. It is a slope of 1, crosses at 2. We're going to press second function graph, which will bring up the table. And we have x is less than or equal to -1. So we're going to go down to -1 here. X is less than or equal to -1. So -1, 1 is our first point. And since it is a less than or equal to, this is a closed circle. Right? So we're going to get, so less than or equal to -1. We're going to go back, -2, 0. -2, 0. Going to go back, -3, -1. -3, -1. Notice that this slope is going this way from left to right is rise 1, run 1. So we're going down and to the left. Down 1 to the left 1. Down 1 to the left 1. This is how you could save some really good amount of time. I mean, you still want to check it, but I mean, honestly, if you have -10, -8 on your graph, -10, -8, you definitely did everything correct, and we do. All right, remember this is a less than or equal to, so that means you're going to connect all those points with an arrow on this side right here. And then this is f of x equals x plus 2. When x is less than or equal to, for x that is less than or equal to -1. All right, and now we're just going to go ahead and we are going to do f of x equals 1. So grab your calculator again, y equals f of x equals -1, and that's the graph. It's a horizontal line. All right, so f of x equals 1. And remember, x has to be greater than -1, is less than 1. That's all they want. All right, so I put -1, so that's +1, so it's wrong. So clear that out and put 1 in. That's graph, and it's x is equal to 1. All right, y is equal to 1. That's what they want you to graph. So between -1, so that means -1 is where you are going to graph first. So -1, 1, 0, 1, and then 1, 1. So all these 3 points right here on the bottom, that's all you have to graph. So it's -1, 1. And since this is an open circle, because this is open, it remains closed. It's already closed, so it's included. So we're just going to make another dot on top of it, but it's not going to be open. It's closed already. And this one right here, which is x1, is right now an open circle. So that section right there is f of x. I'm going to put an arrow to it. This is f of x equals 1, and then semicolon, and then 1. X is greater than -1, and x is less than 1. The next thing I'm going to graph is y f of x equals x squared. So you know this is not going to be linear. So we're just going to put x squared. This is going to be a U shape. And that's what it is right there. So we're going to press second function table, just like we would do if it was a linear function. And we are going to go to f of x equals x squared. That is the third one that we are graphing. And then x is greater than or equal to 1. We're just going to go back to the calculator. See 1, 1. That is our first point. It is a closed circle. So this is a closed circle. So there's the 1, and it actually closes that open circle that we had here in that second function. So we have 1, 1, and we have to graph everything that is greater than or equal to 1. So 2, 4, and then 3, 9. So 1, 1, 2, 4, 1, 2, 3, 4, which is here. And then 3, 9 up here. Now, this is a little bit tricky, but I'm just going to tell you, go back to the graph. Notice that it's curved. So that's the way that you have to actually try your best. It's not a straight line. It's a curve, like kind of like that. So it's kind of like a curve like that. I had trouble drawing it only because I'm on a pad here. So it's a little bit difficult. I don't have the board, but still, it should not be a straight line. Remember, this is not linear. It is a nonlinear function, so that's basically a U shape, or that part of the U shape. Remember, its x is greater than or equal to 1, and that's all you could fit. You could basically just fit 1, 1, 2, 4, and then 3, 9 on the graph. And that's it. That's the piecewise function of two linear functions and a nonlinear, which is x squared. And that is it. Okay, here's some extra graphs here. So I put 1/2 x plus 4 in. I have to graph it if x is less than 2. So I'm not even going to the graph. I'll just go less than 2. So I know that 2 is my first point, and there's 2 right here, 2, 5. So I'm going to go to 2, and then 1, 2, 3, 4, 5 up here. It is an open circle because that is just a less than 2. So I'm going to skip the 1 and 9 over 2. I'm going to go to 0. And there's 0, 4. So 0, 4 is right here. And it has a slope of 1/2, so I'm going and to the left 2. Down 1, to the left 2. I can see exactly what I'm doing here. And then I'm just going to go connect that. And that is y equals 1/2 x plus 4 if x is less than 2. So now I am going to do the next one. It's -1/2 x plus 2. So y equals, I'm going to clear that out. And I'm going to put a negative right in, negative 1/2 x. Press graph, and it's going down from left to right, as it should. I'm going to press second function table, and it's supposed to be x is greater than or equal to 2. So I'm just going to go down to 2, and 2, 1 is my first point. So I'm going to change that 2 to 1, and that is a closed circle. And then 3/2, I'm going to skip, 4, 0, which is right here. And notice that the next one is 5, negative 1/2, 6, negative 1, which is right here, and I can't graph anymore. So that's why it's a closed circle on this right here. Going to connect that and put my arrow on the end. Like that. And we're going to just label that y equals 1/2 x plus 2. And we're going to put that semicolon, and we're going to put this down here. X is greater than or equal to 2. And that's it. Medium section, y equals 3. We're going to graph that. So just going to put y equals 3. Graph, you know it's a horizontal line at this point. So x has to be less than negative 3. So you go to negative 3, and on your graph right here, you can see that negative 3, everything on the y side is 3. So negative 3, 3, negative 4, 3, negative 3, open circle, negative 4, 3, negative 5, 3, negative 6, 3, negative 7, 3. And there's your line. Put an arrow, and you put y equals 3, semicolon, x is less than negative 3. Then x plus 1, y equals x plus 1. Graph it. Second function table, x is greater than or equal to 0. X is greater than or equal to 0, so 0, comma 1 is my first point that I have to graph. 0, comma 1, and let me just get the blue. 0, comma 1 is here. It is a closed circle, nice big closed circle. 0, comma 1, 1, comma 2, 2, comma 3, 1, comma 2, 2, comma 3, 3, comma 4, and you go up like this because it's a rise of 1 and a run of 1. Slope of 1. Connect those points. You put an arrow at the end. It's a pretty sad looking arrow. Move it over, it looks a little better. And it's y equals okay. I can't believe it. And that is it. For this one, there's 3. This is a more difficult one. 3 functions. So we are going to move this over as much as possible. There we go. Y equals 3. And again, horizontal line. The x has to be less than or equal to 1. So we're going to go less than or equal to 1, which is 1, 3. So we're going to start with 1, 3, and that is going to be a closed circle, 1, 3. Then 0, 3, negative 1, 3, and so on and so forth. All the way down, all the way to negative 7, 3. Then we are going to take our ruler and put an arrow at the end. So this is f of x equals 3 if x is less than or equal to 1. Then we're going to go to 2x minus 5. Y equals 2x minus 5. That's it. We're going to press second function table. We're going to get, so this is between 1 and 3. So between 1 and 3. So it's only 3 points. And this one's open. So let me just go ahead and put this in a different color because we do want to see this. 1, negative 3. So 1, negative 3 is down here, and that is an open circle. 2, negative 1. So 2, negative 1 is here. So I am messing up here. Wait a minute. Okay, let's start again. So this is 1 and 3. I went down to 1 and negative 3. Oh, I got it. I had it right. So this is 1 and negative 3. 1, negative 3. No, I didn't have it right. That's the open circle there. And then 2 and negative 1, which is right here. And then 3 is a closed circle, 3 and 1. And we finally got that right. Connect that right there and stop right there. So it's a little bit hard to put down, but it's f of x equals 2x minus 5. X is greater than 1 and less than or equal to 3. Okay. And then y is equal to negative x plus 4. And there's the graph. Goes down from left to right, negative. So now we have x is greater than 3. So 3, 1 is our first point that we're graphing. So 3, 1 is the first point we're graphing. And since it's supposed to be an open circle, it doesn't matter. It's closed already on that side. So we're going to leave that. So 3, 1. And then greater than 3. 4, 0. Right here. And then we're going to go down because this is a negative 1 slope. Just like that. And then we're going to have a problem here with this. Yep, right there. Since it's greater than 3, I'm going to put an arrow there. And we're just going to put f of x is equal to negative x plus 4. X is greater than 3. And that is the mess that it is. All right, mid-lesson assessment. Go ahead and see if you could graph this. And again, we have a lot of information here that they give us. So we're going to press y equals, and we're going to clear that out. First thing that we're graphing is f of x equals negative 2. So we're going to graph that. and that's a horizontal line. So we're going to press second function and table, and we're going to see our tables. So just remember the x has to be less than -3. So the first thing that we're going to do is -3, -2. And this is an open circle. -3, -2. Less than -4, -2. -5, -2. And it just goes along the line right here. There, remember, it's horizontal. And then you connect those points. And this is f of x equals -2. Semicolon, x is less than -3. Then we're going to graph f of x equals 1. Graph. Perfect. 1. In between -3 and 1. So second function graph, we're going to go -3, 1. -3, -3, 1. Closed circle. -2, 1. -1, 1. 0, 1. And then an open circle on 1. Right, and that is f of x equals 1, and x is less than or equal to -3 and less than 1. That's why it's open circle on that side. And then the last one is f of x equals 4. That's a horizontal line as well. And you press second function graph for the table. I did it too soon. And we have to graph it at x is greater than or equal to 1. So greater than or equal to 1, 1 is the first point. So 1, 4, 2, 4, 3, 4, 4, 4. So 1, 4, 1, 2, 3, 4 is a closed circle. And then we just go along like this. And 10, 4 is your last point that you're going to be able to fit. And that gets an arrow at the end, and it is f of x equals 4. X is greater than or equal to 1. And that's it. That is the piecewise function. Okay, how do we evaluate piecewise functions, though? We know how to graph them, but we don't know how to evaluate them yet. Well, it's kind of like in reverse. They're going to give you the graphs, and you're going to have to pick the equations out. How do we evaluate? Looking at the equations and the domain, you'll be given the equations for the functions and the domains. You'll evaluate whatever the function for whatever number is in the domain. You have to look at the graph, go to the x-coordinate, find the y-coordinate that lands on the graph. Let's get to it. So, this is our first explore. So can you identify the equations of the lines that contains each segment? Okay, so we are going to basically take the equation first. Let's see if we can get the equation. The blue line is clearly a rise of 1, a run of 1. And I want you to think of everything in from left to right. So this has a positive slope. This blue line has a positive slope. It goes up from left to right. Even though it starts here, right? it starts there and it continues in this direction, like to the left. You're reading it from left to right, so this is a positive slope. If you're looking at a positive slope, if you continued this line, it would go right there. So the y-intercept would be 2. So this rise over run is 1. So it's y equals x plus 2. And that's what this would be. So this would be y equals x plus 2. And we're going to leave the domain for later. All right, so the red equation, this right here is the y-intercept. So it's 1, 2, 3. And then it also has a slope of 1. So this is x plus 2, x plus 3. Y equals x plus 3. Now the green, we're going to talk about, if it continued like rise of 1, run of 1, down 1, left 1, would be right there. So the y-intercept would be 1, and this also has a slope of 1. So we're going to just go ahead and put that on there, y equals x plus 3. And remember, we did not put any of the, this is y equals, any of the domains. We didn't figure out any of the domains. But now let's go ahead and figure out the domain of the blue. So it starts here. So this right here is -1 on the x. And it goes on forever like that. So it is x is less than or equal to -1. Right? And the red would be like 2 numbers circled. So that means you have a compound inequality, and it's greater than -1, and it's less than 1, because this one is 1 right here. Down. The green domain starts at 1 and is not circled on the other side. That's an arrow. So that means it's just x is, and that's supposed to be green, and that's supposed to be x is greater than or equal to 1. Right? So if you put this all together, right, you have f of x equals x plus 2. So let's go to blue right there, x plus 2. And then semicolon, and it is x is less than or equal to -1. And then in red, we have y equals x plus 3, semicolon, x is greater than -1, open circle, and less than 1, both open circles. And then in green, we have x plus 1, and x is greater than or equal to 1. And that's basically everything there. That's how you would identify the lines of each, the equation of the lines of each, and then figure out the domains. All right, so this is more practice. We're going to practice writing each piecewise function. Okay, so we're going to start with this line right here, this one. So we're just going to start with this line, and it's a y-intercept of 3. So the y-intercept of 3, and then we're going to just try to figure out the slope. So we'll just figure out the slope right here. We're going to take that point, the y-intercept, and just going to look for another point, the x-intercept. And I'm just going to go a rise and a run. So the rise is 1, 2, 3. This is positive, and this is positive also. So rise of 3, run of 2. So we have f of x equals 3 over 2x plus 3. And let's go ahead and do that domain. Since there's only one number circled, I know that is a single inequality. It goes from 0 to infinity. So that means 0, its x is less than or equal to 0 since it's a closed circle. For this one, we have a y-intercept of 5. So the b equals 5, and then we're going to search for, there we go. And this one goes down from left to right. So this is negative 1 over 2. So this is negative 1 over 2x, and then that is plus 5. And again, that is x is now greater than 0. And that's basically it. Okay, so this is like 3 parts. So we're just going to go and look at this part first. All right, so this is, if it's continuing, we're continuing it like this. And you can mark up the graph as much as you want. The y-intercept would be 2. And actually, the whole line is y equals 2. So y equals 2. And it is from negative 4. I'm going to put semicolon. X is less than negative 4. Because as an open circle, it does not it's not a less than or equal to. It goes in this direction, to the left. All right, so now we have this second line right here going this way. It's definitely a positive slope. It goes up from left to right. So we're just going to take this point right here, which I shouldn't have closed because that's an open circle. That point and the y-intercept. Or you could go from the y-intercept to the closed line. All right, so we're just going to go and draw like this. So it's 1, 2, 3, 4. And then this is 1. So 1/4 x. And the y-intercept is 3. 3. And then semicolon. It starts at negative 4. So this is a compound inequality. I'm going to leave some room here. That is greater than negative 4. And less than or equal to 4. Because there's a closed circle on 4. All right, and then we're going to talk about this line right here. And again, I'm just going to go down and to the right. So that's down 1 and to the right 2. So that's negative 1/2 x. And then I'm going to continue. If I go down 1 to the right 2, I have to go up 1 to the left 2. Up 1 to the left 2. And that's 5. So plus 5 is the y-intercept. And then it's semicolon, starts at 4, all right, and it goes on forever in that direction, so its x is greater than 4. And that's it. All right, so this one right here, okay, you draw your brace, and then we're just going to go ahead and look at this line. This is a positive slope. They're both positive slopes. They're going up from left to right. We are going to, I'm going to take the y-intercept, the x-intercept, and this one right here. You know this is a 1 slope. All right, so the y-intercept is a 5. That is 1 slope. So this is x plus 5. And then the semicolon right here, we're going to start at 2, and it's a closed circle. So we're just going to go x is less than or equal to 2. All right, and this one right here has a 1 slope as well, x, And then I'm just going to go and continue that down. That is a direct variation. So it's just x. And it starts at 2 and goes forever. So this is x is greater than 2. And that is how you do that. You're writing your piecewise function based on the graphs that they give you. All right. So now we're just going to practice identifying, evaluating the piecewise function by looking at equations and not graphs. And I think this is easier than doing the actual graphs, but you might think differently. So it says find f of 3. So just remember, these are two, like this is one complete function, but this is two equations. All right. So you have to identify what domain works when x is 3. All right, because they're giving you the x of 3, right? So you're basically substituting that directly in to each equation. But the thing is, there's only really one function that will satisfy x of 3. So since this is x is less than 2, if this is x is less than 2, then if you substitute 3 in, it doesn't work, right? 3 is not less than 2. So if we say 3 is less than 2, no, that is not correct. So that means this one, you can't substitute that 3 in. It doesn't work. They don't want that. But 3 is greater than or equal to 2. And that's a yes. So we substitute this 3 into here, and we get 3 in return. All right, because it's just f of x equals x. All right, and so let's go ahead and see if we could do this. f of negative 2. Which of these functions, which of these domains does x equals negative 2 satisfy? Well, we have f of negative 2, so we're just going to go ahead and look at the domain x is less than 2. Negative 2 is less than 2. So negative 2 is less than 2. So that is correct, and that means I have to use this one. So negative a half times, what it would be is negative a half times negative 2. So you would just do negative a half, if you really wanted to do this, times negative 2, and that would be a positive 1. Or you could just go ahead and put this directly into the calculator, and I'm just going to move this over so you can see. Move this over. So I'm going to clear that out. Press graph, clear it out, and then press y equals, and then negative 1/2. So you're going to press alpha x, negative 1 over 2 x, if you really want to, and then press second function table, and then you would go to negative 2, negative 2, 1. But I mean, I'm sure you could do that in your calculator, but that's what you were basically doing there. 1 is the answer. When 0 is less than 0 is less than 2. So you're using the same one, right? So you're using this one. So on the top of here, I'm just going to put negative a half times 0. And you don't really have to use your calculator for that. It's 0. So you could see that when you substitute 0 in, it's right here. Since I have that same function in, you get 0 as a return. X, Y. Input, output. Now 2. Which one does 2 go into? Well, x is greater than, so 2 is greater than or equal to 2. So that is yes. So we're going to put a check mark, and we're going to substitute it into here, which is 2. And that's it. So let's go down and see if we could do these. We have f of x equals 5 and f of x equals negative 2x plus 3. So just remember, this is the y. It's like y equals 5. Y equals negative 3. When x is less than or equal to negative 3 and x is greater than negative 3 for this one. So negative 6. Which domain does negative 6 fit into? So x is less than or equal to negative 3. That means negative 6, if you kind of just put that negative 6 in for the x, negative 6 is less than or equal to negative 3. So that means you're using this one, and negative 6, 5 is your answer. It's like y equals 5. Every time y is going to be equal to 5. This one right here is negative 2x, so this is 9. So 9, that's greater than negative 3. So that's the one that you would use. So that's check mark right there. Y is 9 is greater than negative 3. So that is the one that you would use, negative 2x minus 3. So you would just do, on the bottom here, negative 2 times 9 minus 3. Or you could just put in y equals negative 2x minus 3, press second function graph, and then you would go down to 9, and there's 9 is negative 21. 9, negative 21. And it makes sense because negative 18 minus 3 is negative 21. So you can do it either by hand or whatever you want. All right, so f of 7, which domain does that fit in? Well, 7 is greater than 2. So you're going to use this one. So 5 times 7 minus 4. So I'm just going to go ahead and put that directly in because I don't trust myself. So this is 5x minus 4. And I'm going to press second function graph. And remember, they gave you a 7, so the output is 31. The input is 7. That means you have to use this because 7 is greater than 2. Now, I'm going to leave this 5x minus 4 directly in my calculator, and anything that is greater than 2, I'm just going to get done right. I'm just going to get finished now. And there's nothing greater than 2. Right? So now I'm going to go back to my calculator, and I'm going to put y equals, and I'm going to clear that out, and I'm just going to go negative 2x plus 1. And I'm going to press second function table, and I'm going to look at all the x's that they give me. F of 2. Since x is, so 2 is less than or equal to 2. That's good. So I'm using this negative 2x plus 1. So when x is 2, the y is negative 3. When the input is 2, the output is negative 3. And just remember, I substituted in negative 2x plus 1 into my calculator, so all the inputs and outputs are, the outputs are going to be correct for the inputs. So this is negative 3. So negative 3 is less than or equal to 2. So that's why I'm using negative 2x plus 1. So now I have to go to negative 3 and see what my output is. Negative 3 input, output 7. And then 0 is less than or equal to 2. So we go to 0, and 1 is my output. That's it. That's why I like this one a little bit easy. It's a little bit easier for me. I don't know if it's going to be easier for you. But so now we have x squared minus 1. So I'm just going to go and put x squared minus 1 in, and then press second function graph. I don't really care what the graph looks like. All right, so 0, I'm just going to stick with this. All of the x's that are less than or equal to 0, I'm going to go and find the outputs for. All right, and so f of 0, when the input is 0, I'm using this one. So that means that I have to look at when x is 0, the output is negative 1. Negative 3 fits into this as well. Negative 3 is less than or equal to 0. So I'm going to go to negative 3, and it's 8. Now, 8 is not less than or equal to 0. 5 is not less than or equal to 0. 4 is not less than or equal to 0. 1 is not less than or equal to 0. So I'm going to go back, and now I'm going to go to the second one. This is 2x minus 1. Second function graph. Now, it's only between, I'm looking for numbers that are in between 0, not including 0, and including 5. So, 8, that is not between 0 and 5. 5, that works. So I'm going to go to 5 in my calculator, and when there's an input of 5, I'm using the second function, this second equation, and the output is 9. And if you do 2 times 5 is 10, minus 1 is 9. I'm just not doing it by hand. 4 is in between 0 and 5. So I'm going to go up to my calculator. 4, 7. 8 is not. I said that before. 1 is. So x is greater than, 1 is greater than 0. So I'm going to go to 1, and the output is 1. When the input is 1, the output is 1. 2 times 1 minus 1 is 1. The only one that I'm left with is 3. And for the 8 is greater than 5. So that means it's 3. All right, if you graphed y equals 3, like say, if you graphed y equals 3, think about what you would have. You'd have all 3's. And that's why it's just 3. Whatever x it is, just greater than 5, 6, 3, 7, 3, 8, 3. And that's what it is. And that's why it will always continue 3. And that's why 8 is 3. And that's it. All right. And so, back to evaluating the function. Piecewise function by looking at the graph. Remember, an open circle means that the function is not contained there. So it says find f of 3. Remember, this is the x. So find f of 3. Open circle, that does not work. It's not contained there. So f of 3 has a y. This input is 3. The y is negative 2. So we say f of 3 equals 2, negative 2. When the input is 3, the output is negative 2. Now, we're going to use the same graph. Find when x is negative 4. So x is negative 4. What's the y? Negative 3. F of 1. F of 1. What's the y? 2. When f is 4, what's the y? Negative 2. Super easy. Take a look at these. When x is negative 4, f of negative 4. So we're going to go to negative 4. What's the y? 1. When x is negative 1, what's the y? 1? No, it's an open circle. So you're going to go down to the closed circle. It's negative 2. When x is negative 1, the y is negative 2. When x is 1, what's the y? It's right there. It's negative 2. When x is negative 2, what's the y? 4. When x is 1, what's the y? 1. When x is 2, what's the y? Open circle, skip it. It means it's not included. This is a closed circle. It's 3. When x is 3, what's the y? 3. When x is negative 4, what's the y? I think this is negative 1, negative 2, negative 3, negative 4. Negative 4. I don't like the way the graph is numbered, but when x is negative 1, what's the y? Open circle? No. Closed circle? Yes, that's 2. When x is 1, what's the y? 1, 2. When x is 2, what's the y? 5. 1, 2, 3, 4, 5. And when x is 5, what's the y? Negative 1. That's it. That's all you have to do. When x is negative 4, what's the y? Very difficult to see, but it's 3. It's 2. When x is 0, what's the y? 0. When x is 3, what's the y? It's 3. And that is it. So, which function is represented by the graph, the exit slip? Intercepts. All right, so the y-intercept of this one is 1. So the b equals 1 for this one. I'm just going to write on the graph. And the slope, all right, we're just going to take the y-intercept in this, and we're just going to go, we could go by this and this. I like to use the y-intercept sometimes. This is a positive slope. This is 2, this is 1, so the m is 1/2. So this is f of x equals 1/2 x plus 1. 1/2 x plus 1. And that is that one. And in this one right here is negative 1, negative 2, negative 3. So the b is negative 3. And this has a negative slope. You see how it goes down from left to right? Just ignore the arrow. The only reason why the arrow is there is because it's really here is that it's a piecewise function. But it's still going down from left to right, if you could see it. All right, this one and one slope. So this is f of x equals negative 1x, which is negative x, minus 3. All right, negative x minus 3. All right, so I'm just going to go and negative x minus 3. That's good. So this one could be the answer. A half x plus 1, that's good. X plus 3, no, that's negative x plus 3, that's out. Negative x plus 3, that's good. 1/2 x plus 1, that could be the answer. Negative x, this is out. All right, so we have two choices, A and C. So if you just take a look at this one right here, let's see what is going on with the domain. It starts at 0, which is greater than just 0. Right? That's greater than 0. Open circle goes forever in that direction. This one here, by the way, x is greater than 0. That's that one that's linking up to this, and that's linking up to that. So we still have to go on. Right? By the way, this is plus 3, so I kind of messed up right there. So A has to be your answer. Yeah, so this one could not be the answer only because with the choice right here, as far as the negative x plus 3, the y-intercept is not plus 3. All right, so it is minus 3, the y-intercept, and this is plus 1, and it's a half x plus 1, which matches up with everything. So you really didn't even need to do the domains. But the thing is, if you were doing the domain, it starts at 0, this line right here, starts at 0 and goes, it's less than, goes in that direction forever. So it's less than, and it's a closed circle, so it's less than or equal to. So A is your answer, definitely. Okay, so the lesson did, it's basically finished, but this is reinforcement, and we're just going to go ahead and do that. All right, so we're going to just go ahead and graph these piecewise functions. So this piecewise function. And so the first thing that we're going to do is go ahead and use our calculator to graph x plus 3. So we're going to have x plus 3, and we're going to graph it. So that's x plus 3. So we're going to press second function and table. So we have x is less than 5. So we have to go to 5, and we have to graph everything less than 5. So 5, 8 is our first less than 5. So 5, 8 is our first 1, 2, 3, 4, 5. That's our first point, and we're going to go up to here. Since it is just a less than, we're going to have a nice big circle. So 5, 8. 4, 7, 3, 6. So 4, 7 is right here. 3, 6 is right here. That's kind of sloppy. But this is a positive 1 slope. So you can see exactly what it's actually doing. This should be the y-intercept. And if you check your calculator, 0, 3, that is your y-intercept. And you're just going to go down 1 to the right, to the left 1, down 1 to the left, down 1 to the left, and just keep on going in that direction pretty much until the graph runs out. Once you're finished with that, this open circle goes down like this, and we have an arrow on the end, just like that. So we're going to just put down f of x plus 3 equals x plus 3, semicolon, x is less than 5. Now the next one is negative x plus 13. So we're going to just press negative x plus 13. And we're going to graph it. Now notice that we are not ever going to see the y-intercept for this one. So we are just going to go ahead and graph whatever it is that they're asking us to graph. So the x is greater than or equal to 5. So this is 5 right here. So let's go ahead and see exactly what our table says. So just to go down to 5, that's 5, 8. So this is 5, and 8 is right there. So that is a greater than or equal to. So just remember, if we're graphing this point and it's greater than or equal to, that means it closes that circle. So 5, 8, and then 6, 7, 1, 2, 3, 4, 5, 6, 7, which is this, and it has a negative 1 slope. Just like that, you connect the points, and again, you put the arrows, and you put f of x equals negative x plus 13. semicolon, x is greater than or equal to 5. And that's your final graph. All right, just remember, when you have an open circle and a closed circle on the same point, the closed circle takes precedence because, again, that number is included in the graph. All right, it's included now because this whole function, 5, is definitely included in the domain because of the closed circle. All right, extra reinforcement, and here we go. For the domain and the range, we could just basically put them in, but just let's concentrate on the graphing first. So we're talking about graphing here, and this is basically what it is. This is negative 1/3 x minus 5 if x is less than 0. So I put an open circle around there, and I graph that section of the graph. And then 1/3 x minus 5, and then graph that section. So basically, you're just figuring out that this right here, this is what closes in circle. So 0 is included. So if you're talking about the domain, if you're writing this as an inequality, or even if you're writing it as an interval notation, which is what I'm going to do, I'm going to go ahead and just put down that this is negative infinity, goes to the left forever, and this is positive infinity, goes to the right forever. The range itself, it's basically at -5, and it includes -5. And it is positive infinity because it goes up in that direction forever. And that's really it. For the next one, if you just take a look at it, it is y equals 2x plus 3. Grab your calculator, and then you'll see that the y-intercept is 3. You have to go to x is less than 1. X is less than 1. Okay, so the two graphs are on there. I graphed y equals 2x plus 3 if x is less than 1. That's this way. And then y equals 4x minus 6 if x is greater than or equal to 1. That's that way. So let's talk about the domain. The domain, we're looking at the x's and the y's. The x's only. So this is, again, we're going to talk about negative. It goes on forever to the left, and it goes on forever to the right. So that's negative infinity and positive infinity. The range itself, remember, the range is just the y's. So it goes down forever, and it goes up forever, and it includes every single number, because this is an open circle. So we're talking about the same thing. Negative infinity, because it goes down forever, and then positive infinity, because it goes up forever. And that is it. Okay, so here's the graph of the final question. Negative x, f of x equals negative x right here, and that's x is less than or equal to -2, so it goes in that direction forever. Then the f of x equals 2 is from here, -2 to 1, the open circle being on the 1. The -2 is an open circle as well, but the thing is, this one already had, this partition already had a closed circle, so that it stays closed. And then it's f of x equals 2x minus 3. So this is the graph of 2x minus 3, but only for f is less than or equal to 1. And that's a closed circle on that. So what's the domain? The domain goes forever to the left. So we're just going to talk about the parenthesis, and then the negative infinity. And then how far right does it go? Well, it goes to the right. It stops right there. It's 1. and that is a closed circle on that one. So 1 is included. So it is a bracket. So the range, how low does this graph go? It is a negative infinity graph, goes forever in the down direction. And then does it go forever up? It does. I'm just going to write the range in because it is different for each part of this function. See how it stops at this is -1, and actually it includes -1, but it doesn't include 0 or anything in between -1 and like almost 2. So I'm just going to write y, and there we go. So y is less than or equal to 1. Y is less than or equal to 1. And then this one is right here. See how like it's separated? And then it's y is greater than or equal to 2. And it goes up forever. 2 is included because of this closed circle and this line right here. So that's basically it. Okay, that ends the lesson. Hopefully that helped. Thank you for watching. Bye.